What's going on, guys? So today we are going to go ahead and learn how to essentially take a Flask application, put it in a container, put that container on Azure, and deploy it. Okay, so we're going to walk through this step by step. There are four main steps. Step one is going to be create the Flask application. Step two is going to be create the Docker file. Step three is going to be create the Docker image. There's going to be more than three steps, or four steps. Step four is going to be build the Docker image. Create the Docker image, build the Docker image. Step five, we're going to create an Azure Container Registry, which is actually just like the Docker Container Registry. It's a repository for containers, and we're going to go ahead and then push our newly created container up to that repository for containers. After that, we're going to go ahead and deploy it on a platform, a managed service known as Azure App Services, and it's going to host our containerized Flask application, and we're going to do this all in hopefully 20 minutes. So let's go ahead and do it. All right, so first thing we're creating a Python application. So we're going to go ahead and create our app.py file. And the next thing we're going to do is go ahead and create a virtual environment. And we're going to be using Python 3.8 for this. So I've gone ahead and basically what I've done, I installed Python 3.8, and then I did a pip3 install virtual env. So I already have this package here. So it's virtual env. So I already have this package here, but essentially what it is it allows us to isolate our Python packages in this specific directory so they don't affect our global directory in our computer. And that allows us, so when we're developing multiple different Python programs, we don't actually mix up any packages in there. So we don't want to do that. So we're going to go ahead and create a virtual environment to isolate our Python packages that we download in this directory here. So in order to do that, we say virtual env venv, and it's going to go ahead and start to create that for us. So we're only going to need one package here, and that is going to be the Flask package. So we're going to go ahead and install the Flask package as soon as this virtual environment is created. It says we notice a new virtual environment has been created. Do you want to select it for the workspace folder? Doesn't really matter, but we'll say yes for the heck of it. So what it's doing here is installing the tools for that in our virtual environment that are necessary for essentially downloading and building Python packages. So when this is done, we're going to go ahead and now say pip install Flask, and that'll install Flask. Now we can say from Flask, import Flask, and then we can create our API server object. So we can say app equals Flask using the function that we imported from our Flask library, and we're going to pass the name. We pass the name as the parameter there, and that's just the name of the file here. So now what we're going to go ahead and do is now we're going to go ahead and add an endpoint. So we're going to say app.route, and we're just going to have the base endpoint. So essentially, there's not going to be any additional routes thrown on there. This is going to be the index page, the home page essentially. And then we're going to define a function under this decorator that essentially is going to return the text hello world. So we're going to keep this super simple here. There should be a function, so it should look like that. All right, so now that we've got that, we're going to go ahead and go. So if name equals main. So if this is the I misspoke earlier when I said name would be the name of the file. So name is in this case is main. It's the file that we're running. It's the main file we're running. This is how Python interprets it. So if name equals main, app.run, and we're going to specify a host is going to be 0.0.0.0, and our port is going to be 80. All right, so again, the host is the IP address of where the application is going to be, where the IP address we assign to this running web server, and then the port is where it's going to be receiving traffic. And in this case, it's HTTP traffic, so it's going to be port 80, and that'll take care of that. So we're going to go ahead now, and this right here should now run. So in order to activate, I didn't activate the virtual environment. Okay, so we're going to retrace. If you installed Flask there, do a pip uninstall Flask because that installed it globally. So we'll get rid of that, and now we're going to say, so if we do an ls here to see what we have a .vs code, which are just some metadata about the VS Code editor that's relevant to us. So we're going to say /vnv scripts activate. And that'll go ahead and activate our virtual environment. This is for a Windows environment. So if you're on a Windows, a Linux-based, a Unix-based environment, the command is going to be source vnv bin activate, and that'll take care of that for you. Okay, so now we can go ahead and install Flask. All right, so once we install Flask, what we're going to need to do is create our Docker file. And in our Docker file, what we're going to do is we're going to go ahead and pull the latest Python Docker file image. So what we can say is from Python 3.8.0. And what this is going to do is essentially pull down what a Docker container does is it virtualizes a kernel, and what that means is it basically allows us to use the very bare minimum amount of resources when we're and isolate our application with these bare minimum amount of resources. Then we can go ahead and pull in whatever other dependencies we might want. So we're going to say from Python 3.8.0, then we're going to create a working directory. And that's going to be user source app, and so this is going to be the Active Directory, as if we were just clicking around down here, whatever. This is my Active Directory. This will be our Active Directory. Now we're going to go ahead and say copy. We're going to copy the requirements. So in this case here, we want to be able to just copy over the specific requirements or our packages, or a list, we'll say. Well, it makes more sense if I do it, but a list of requirements essentially that are the packages that are required for this application to run. So what we can do here is say pip freeze requirements.txt, pip freeze, and then with a little a caret, I think it's called a caret, but a caret facing to the right, and that'll essentially pipe the requirements from pip into a requirements.txt text file and create that. So now we did that, and we see this requirements.txt with all the dependencies that are installed in our current virtual environment. Okay, so now we can go back to our Docker file. Now what we want to do is actually copy that requirements file over into our Docker file. So we're going to say copy requirements.txt into that working directory, and then we want to go ahead and say pip run. We got to run the command run pip install -r requirements.txt. So what that'll do is go ahead and actually install iteratively all of those requirements for us, and then we can go ahead and have a command that executes our actual application after we copy that over. So we're going to go ahead and say copy dot, which will actually copy over all of the files that are in that local directory that we're in currently. So what you see here, basically what we're aiming for is this app.py. I'll copy that over, and then we were going to go ahead and once we copy over that app.py file into our Docker container or Docker image that we're building here, then we can go ahead and define an entry point, in which case we just call the command python app.py. All right, and so when we call python app.py, essentially what we're doing is we are going ahead, and so we'll review this from the top, but essentially to finish, we're just executing the program. But let's review this. So again, we're pulling a virtualized kernel with just enough resources to essentially run our Python program. We're defining a working directory. We're copying the requirements. File into that working directory. We are then running pip install -r requirements.txt to install all those requirements in this new image we're creating. Then we're copying over our app file, and then we're defining an entry point for how we're going to execute this. And now the reason we're copying these things over in steps here is because Docker actually caches these individual build steps to make it faster to build subsequent images when you're rebuilding this image. So you do this kind of in separate in layers essentially. So that's what's kind of going on here. So now let's go ahead here and try to build this image. So we can verify that if we wanted to, we could run our application first here. So we can say Python app.py, and an attempt is made on a socket. I might have a Docker process running there. I do. Docker kill confident Louis. Aw. All right. Nope. Confident Louis. Oh, confident Lewin. There it is. Okay, so that's a way you. Oh, by the way, a couple commands I typed there. Docker PS. This will show you all the Docker processes that are running. Previously, I did have a Docker process running, and it was listed as you can see here. This right here. But now I killed that process, so that is no longer running. Poor confident Lewin. So now we're going to go ahead here, and we're going to actually we're going to run this container, verify that our app is working. All right, it is. We don't need to go through all this. So we can see it's running on this port here, 0.0.0.0 port 80. And now we can go ahead and actually build this Docker image. So we can go ahead, we're going to do that now. So we're going to say Docker build -t, and then we're going to tag this image. So we're going to tag this image with a some kind of metadata that allows us to reference it. So Docker build -t, and we're going to call it Flask app, and just Flask app 0. Or Flask app, or just gonna, yeah, Flask app 0 we'll call it for the first iteration. And then we're going to put just a dot, which symbolizes that the Docker file that we want to build with is located in this current directory. So now we can go ahead and do that, and hopefully this is going to work for us. So now what it should be doing is, again, it's going to pull down that initial Python 3.8.0 Docker image, which might take a little while, and then it's going to go ahead and run and execute these commands. So while it's doing that, we're actually going to flip over to the Azure cloud, and that was faster than I thought. Okay, so we're going to flip over to the Azure cloud, and what we're going to do here is create an Azure app, an Azure Container Registry. So what we can do is, if you guys haven't yet, go ahead and sign up. You get $200 in free credits for Microsoft Azure, which is nice for hosting your own random applications if you want to, for say school projects or for your own money-making endeavors or whatnot. So we can go ahead and put, we want to go to Container Registries in Azure. We're going to add a container registry. And again, this is going to be a repository for a container. We're later going to push it up to this, and then we're going to go ahead and reference this container, use this container in this repository when we're and deploy it directly from there. So registry name, we can just call it Flask app. That's already in use. So we can say these are global namespaces, so they have to be somewhat unique. So we're going to say John's Flask app. John's Flask app, Flask apps. And so now what we're going to go ahead and do, we have a subscription choice. Now, so when you guys sign up, your subscription is essentially like, okay, a free trial, pay as you go, pay with Microsoft support, like all these different things. It's just a subscription is a way to isolate the cost of the resources that are going to exist within that subscription. So now we're going to go ahead and create a resource group. And a resource group is similar to what you might imagine a class to be in a program. So essentially, it's a way to logically isolate a set of resources, a set of VMs, a set of services on Azure Cloud. And so for the Azure Container Registry, we need to select a logical isolation for it. And so we're actually just going to create a new one as we go here. So we're going to go ahead and call this one John's Flask apps. Keep it simple here, so we're just going to name it the same as our container registry. Now we have a location. Ideally, you put this location as close to you as possible in this case to minimize any kind of latency when you're pushing and pulling Docker images and whatnot. And then we just have standard, premium, or basic for, I believe it's bandwidth, right? More performance and scale. Yep. So that'll. So we're just going to go with standard for that. And now we're going to go ahead and click create. So what this is going to do is create that container registry. Let's check back and see how this building was done. So it looks like we successfully built our container image. So we can see essentially went through these steps here. So we have it basically go ahead and executed these different things. So you can see it said copy requirements.txt over, run pip install -r, requirements.txt. It installs these Flask and a few of Flask's other dependencies. Then we go down and we see copy moving over the rest of our files, and then we go ahead and we tag our Flask app. Successfully tagged it, so we have a way to reference it with some metadata. So essentially now we can go ahead and test running this thing. So we should be able to say Docker image ls, and this will show us a bunch of Docker images. And right here we have our Flask app 0 that we just created. So if you guys see at the top, you probably will see that as your first one once you've installed Docker on your machine. So we can go ahead now and say Flask. We can go ahead and say Docker run, and we want to specify the port. So we're going to specify the port on our local machine, which is going to be 80, and it's going to map to the port that the web server is running on in the container, which is also 80. So we specify that by saying docker run -p and then 80:80. Then we're going to say a -d, and the -d stands for detached. So we're not going to run this in an interactive mode. It's going to run it as a subprocess, and then we're going to go ahead and then we specify our image. So we say Flask app 0. All right, so you see now it outputs like a little hash there, and now we get to go see. Oh, so something went wrong. So we see that when we run Docker PS, there's no image, there's nothing running. So that means something probably went wrong. So we can try to run this in interactive mode and see what went wrong here. And there's nothing. That's not good. So why would that be happening? If we run docker run -p 80, mapping the ports, Flask app, and we have our Flask app here. No, where's our image? Here's our image. Flask app 0. And we run it. And so it means our entry, Python app.py. So something's wrong here. Pulling our let's try to rebuild without the cache. So I'm not sure what's going wrong here, but we're going to try to debug it a little bit. So we're going to say, we're going to specify the no cache flag, which should make us pull fresh. See, a working directory is still the same. I don't know, that wouldn't make a difference. Let's try, let's build it with a different version here. Okay, so we'll try this again here. We'll try Flask app 1. Okay, so for whatever reason it's working now. So now we can go to localhost 80 and we can see that. So now we get our hello world. I'm not entirely sure what went wrong there. Sometimes it's good to rebuild without your cache dependencies because some kind of caching might interfere with what's going on for whatever reason. So now that means that essentially our image is up and running. We're able to access it by mapping our localhost port or our local port 80 to the container port 80, and then we have this IP address that is defined to run on, which is 0.0.0.0, which you can reference by localhost. So now let's go ahead here and see what we got. So So now what we want to do is push to our Azure Container Registry. So what we can do here, let's clean up. It's my little website I'm working on. Okay, so now we have our container registry, John Flask apps. So now what we want to do here is actually push to that container registry. So how do you do that? So the first thing you got to do is download the Azure SDK. And the Azure SDK is what's going to allow us to log into our container registry from the command line, our Azure Container Registry we're going to log into from the command line, and then we're going to go ahead and push up that container image. So I already have the Azure CLI installed, but if you don't, go ahead and Google Azure CLI. I'll put a link to it in the description, and it's a pretty easy, straightforward install. It'll add this to your path, and you'll have this AZ command that you can run from just run from the terminal. And you see it's going to spit out a bunch of options here as to what I can do with that. All right. So AZ, this is just the Azure CLI. It's a way to directly interface with the Azure cloud from a command line environment. So we can go ahead now and say Azure login or AZ login. And now it's going to put up a window. I'm going to select the account I'm going to log in with here. This is where you would select your account that you want to log in with. And now we're going to go ahead and it says login successful. I can now return to my CLI and boom. So now I can say AZ ACR list. And this is going to say, so it's Azure AZ Azure Container Registry list. And now we can see here is we have our list of Azure Container Registries, and we see login server right here. So we have admin enabled, not yet. We're gonna have to enable that later. And then login server. So just like a Docker registry, you have a way to log into your, or say even a GitHub account, or you have a way to log into it, and then you can go ahead and push and pull from that repository. So now we're gonna go ahead here and say AZ login, and we're gonna go ahead and log in, or AZ ACR login -n, and we want to put in John's Flask apps. All right, so now because I've previously authenticated with my account, it's going to log me into this registry here. So we get the prompt that login succeeded. And now we can go ahead and actually push this Docker image up to that container registry. So let's go ahead here and we say ls, and we have our, I don't know why I did that, let's just kind of have it. So now we want to go ahead and push the container registry. So we want to re-tag our image now. And the way we're going to do that is we're going to say Docker image ls. We're going to look and find our application. We know it's Flask app with the tag 1 is the one we want. So we're going to say Docker tag Flask app 1. And then we want to tag it with the name of the container registry in front of that. So we're going to scroll up here to where it says login server. And we're going to go ahead and copy that. And then we're going to say Docker tag Flask app with the name of the container registry, a slash, and then Flask app 1. So we have Docker tag Flask app 1 referencing the image on our local machine. And then we're basically prefixing it with the name of the foreign repository. And then we're going to go ahead and retag it. So it's going to create another image. So we have our Docker image ls, and now you can see here we have John's Flask app.azurecr.io /Flask app with the tag of 1. All right, so now we want to go ahead and say AZ ACR. Oh no, we want to say Docker push, and we want to push this image right here. So we're going to copy this and Flask app and 1. So now what it's going to go ahead and do is push that entire Flask app up to that container registry, and we're going to see that appear in our container registry here shortly. So when that's done. So guys, I know I was going through this pretty quick. If you've just been watching so far, again, the necessary things to install are Docker on your machine. You want to install the Azure CLI. You want to create an Azure account. You get $200 in free credit. You can deploy all your applications and whatnot. It's a pretty good deal. And then you go ahead and you got this stuff here. So yeah, so now we're waiting right now for it to push that image up to our container registry, and then we're going to go ahead and create an app service with it in Azure. So when we say create an app service with it in Azure, we're going to use Azure App Services. It's basically a managed service by Azure that allows you to host applications with a certain runtime. It also allows you to use, you can also specify it to use containers, and it's going to give us a free public IP address. It's going to set us up with SSL. It's a good solution to one of many solutions to hosting applications on Azure. So this pushing is taking a while. Internet isn't great here. So it's keeping rolling, but yeah. So, anyways, other good things to to know about. These containers are great, absolutely great, because they're a really clean delineation between development and DevOps or deployments, essentially. So again, if you have your application, your developers can put all their configuration files. Imagine you have a room and you have all your configuration. You can hang it wherever you want in the room. Doesn't matter. And then you can just package it, wrap up that whole room in a container, and you can send off that container to your ops team or your deployment team or whatnot, and then they're gonna take then they don't need to know anything about what's inside the container. They can just consider it a single process and run that as a process. And you see that's very powerful. In addition, the reason that containers are excellent is because you can use them with Kubernetes, and we're gonna talk about Kubernetes later because I think it's a really cool thing. But essentially, Kubernetes is a distributed. We're just gonna talk here while this thing's pushing. So essentially, Kubernetes is a distributed operating system, or an operating system for a distributed system. Okay, it happens to use containers as its components essentially. So you have a container. I don't want to go into Kubernetes right now, but essentially you have a container that is wrapped up with additional metadata for control, and then it organizes and scales up your containers relative to your load and whatnot. But anyways, containers make you invariant to your operating system. They integrate with fantastic distributed operating systems, aka Kubernetes, and they can be deployed cross-platform, hybrid in a hybrid cloud, hybrid premise environment. Man, this is taking forever. Okay. So let's go ahead here and we can look at this app service thing. Another thing we need to do is actually set the administrator. So we need to enable the administrator. I gotta find the command for that. I did a while back here. So anyways, what we do when we set this administrator is it allows us to essentially, oops. This is where it'd be nice to have FZF, I believe, or you can just search previous commands. Azure ACR. Aha, here it is. So now what we do is we enable the administrator, and when we enable the administrator, it's going to allow us to actually connect to the Azure Container Registry from the Azure App Service. So that's just something we need to do real quick here. So we're going to run that, update that. Oh, I just realized I canceled the push. Oh, God. Okay. No big deal. Okay, so we enabled the administrator. Let's go ahead and just push that again. So that'll take care of that. Good. Okay, boom. So it should have pushed. Let's go ahead and check it out. So we can go to our Azure, our container registries. We see John's Flask apps. We go down here to repositories, and then in repositories we see Flask app with our version of 1. All right, so now we're in business. We have our Flask app. We containerized it. We pushed it up to the Azure Container Registry, and now we're going to go ahead and set up that app service. So we go to App Services. We're going to create a new app service here. And this app service is again a managed service by Azure. It's going to assign us a public IP address. It's going to give us SSL, and it's going to make it very easy. We have our resource group. I kind of forget what we called it. I think John's Flask apps. The web app name is going to be John's, or let's just call it Flask app. Then we select a Docker container. So you can do code and you can specify your runtime, like, all right, like Python 3 is a runtime, Python 2.7 is a runtime, PHP 7.2 is a runtime, all these different code specifications, essentially, or code specs are runtimes. So you can specify a runtime and then upload your own application, or we can go ahead and do the Docker container, which is better. So now we get to go and select our location. We're going to put it in East US, and we've got our app service plan that's going to go ahead into effect. And this just, again, is just kind of a way to kind of encapsulate what's going on here. And now we go ahead and we go to our Docker configuration. So we go ahead and we're going to run a single container from our Azure Container Registry, and it go ahead and auto-filled because there was only one there. So again, we have our registry, which is John's Flask apps in this case, or whatever you named your registry. We have a Flask app, which is our image, and then we have the tag, which is one. So next up here, we're going to go ahead to monitoring. You can enable application insights, which is a way to get really granular telemetry on your application. But in this case, we don't need application insights, and it's not available to us. Ideally, you do need application insights or any of its analogs, but it's not available to us for this for containers in this situation here. So now we're going to go ahead and set up some tags. These are the tags that you can assign to your resource that we're creating here, which is our resources, our Azure App Service. And essentially, we can assign tags to track costs and kind of filter our global resources that we've provisioned in Azure by tag and track cost by tag and whatnot. So now we're going to go ahead and we're going to skip that. We don't need to do that. So now we're going to review and create. So now Flask app is not available. John's Flask app. All right. So now we review and create, and now essentially the way Azure works is Azure is essentially the way Azure has a thing known as the Azure Resource Manager, and that is largely an API for every single service that you can provision on Azure. And then basically what we're doing here in these blades, they're windows, but they give them fancy names, they call them blades. But essentially these little windows and these little blades that we have here that we're parameterizing essentially. And when I say parameterizing, things like the names, like the resource group, the name of the Docker file, the tags, etc. What we're doing is we're parameterizing what is really a template that is essentially sent to an Azure Resource Manager API endpoint, and then it goes ahead and it provisions that resource given that template. So this is interesting when we look at infrastructure as code later, but yeah, that's what it's doing. So now we're going to go ahead and click create, and we have our deployment that is kicking off here. So this is going to take a little bit of a minute, but yeah. Anyways, guys, I'd encourage you to look into Azure, not just Azure, but any cloud platform, not any cloud platform. Stick to AWS or Azure for now. Those are the most popular in terms of what businesses are going to be looking for if you're looking for a job, or and tend to have the largest set of offerings as well. GCP is obviously a good competitor. However, if we break it down, Azure has a smaller portion of market share, overall market share, than when in contrast to AWS. It has a larger market share than GCP. However, Azure, I believe, makes the most money out of their market share. So it is the platform of choice for many of the largest companies. AWS tends to cater, again, to the whole spectrum of companies, but the Azure is, and Microsoft is very deeply, Microsoft tool sets are very deeply embedded in businesses these days. So it's definitely, to be honest with you, I think Azure Cloud is the best one to learn. Yeah, you can learn AWS. Obviously, that's still in very high demand, but I think that Azure's kind of adopting a real multi-cloud strategy. They're going full force with that. I don't see that, and they're doing, Microsoft in general is doing a lot of open source work. I don't see that from these other companies, and I think that is potentially the best way forwards in terms of a market share and being relevant, is kind of embedding yourself in open source. So now we see our resources popped up here. Deployment is still underway. We're going to give it some time, and then we're going to check out that deployment. We're going to see if we can get this same, when we ran it locally, this little hello world that popped up from running our Docker image locally. We're going to try to get that from our final, our public IP address that's assigned to this Azure App Service that is running here, our container instance. So again, to rehash, guys, we created a Flask app, we created a Docker file, we went ahead and took that Docker file and then created an Azure Container Registry. We took the Docker file, we ran Docker build to create an image, and then we took that image and we pushed that image up to the container registry. And then once that image was in the container registry, we referenced it from our Azure App Service, and it's going to deploy it on the Azure App Service, which is again a highly available service that offers us a whole lot of things to make life easy. So deployment succeeded. Go to resource. And now cross your fingers, guys. When we go to this IP address here, we see URL, https://johnflaskapp.azurewebsites.net. We should get a hello world. But the container has to warm up the first time that we actually visit this address. So if we go here and we see container settings, what we should see is container warm up. When we look at these logs here, we should see some container warm up logs when this loads. So yeah, so I'd be curious to hear your guys' opinions on like all this as well, because there's a lot of ways. Oh, we loaded, and there it is. Hello world. So it worked. But back to what I was saying. So yay, first it worked. That's great. But back to what I was saying. So I would love to hear what your guys' opinions on these sort of things. So do you want to learn more about Docker? This was like a fast and furious, like boom, boom, boom. We're using Docker. We're using Flask. We're using Azure. We're using Azure Container Registry. Using Azure App Service. There's a lot at once. So and we talked a little bit about infrastructure, the templates that are sent to the Azure Resource Manager. Those are ARM scripts, which is Azure's infrastructure as code. There's a lot of directions going, a lot of things, a lot of moving parts here. So what I want to know from you guys is what you might want to learn more about. Do you want to learn more about Docker? Do you want to learn more about infrastructure as code? Do you want to learn more about Azure services? Do you want to learn more about building web apps with Flask? There's a whole lot of different things here, and I just would love to get you guys' input. So anyways, thanks for watching. I really hope you did find this valuable. A thumbs up would be great if you enjoyed this video. Comments would be great. I just love hearing what you guys have to say, and comments are great for the visibility of the channel as well. So all that would be great. And be sure to smash that thumbs up button, smash that subscribe button as well. And as always, guys, thanks for watching, and I'll see you in the next one.